All right. Good evening, ladies and gentlemen, and welcome to this live webinar. And it's a black belt hackathon. It will be for 3 days. Yes. So can you give me the feed for the chat? Yes. Second, I think. Okay. Chalo. So how many of you are already green belt certified? Just type me in the chat box. Okay, just a second, just a second. There is a small change I'll have to do, which is I'll have to, yes. Okay, now you can chat. All right, so how many of you are already green belt certified? Just type me in the chat box. Super. Yeah, it's Amit, Pavan, Rohit, Rajesh, Priyanka, Rice. Okay, Shantanu is still not there. Okay, fantastic. No issues, no issues. Okay, let me just do another setting. By the way, um, just a second. Yeah. This this webinar, meaning this hackathon, is basically is being what you can say live streamed at our YouTube channel as well. Okay, so this is first time we are just trying this. So let me just quickly pin that. Okay, fantastic. Chalo. So all setting is done. You guys are ready for this? No issues. If you are not green belt certified, also you can understand, you can learn from this. Okay. So let me just share my screen first and let me show you how does your black belt curriculum look like. Even though, see, even though you are not yet green belt certified, all right, still look at this. Okay. Now observe what I'm doing here. So this is the your black belt certification course. Now, just for uh, yeah, so Shantanuji, you can decide when to give the examination. Okay, so it's completely depending on what is your preparation. Okay, just send the message on our WhatsApp mentors number, and they will guide you how to, there's a procedure to go for the examination. Okay. Now coming back to the black belt, because today's session is all about black belt. It's going to be a 3-day session starting from today, tomorrow, and day after. Okay, so we will be having these 3 days. Every day it will be 3 hours. We'll go deeper into the concepts of Lean Six Sigma black belt curriculum. Okay, so in this, now you will find green and black common. What does it mean? Now understand this. See, in the DMAC framework, the DMAC framework is absolutely common across white belt till master black belt. All the 5 levels, DMAC framework is absolutely common. So what changes there? What changes is, the tools. As we go up in the ladder, we study more and more advanced statistical tools, graphical tools, lean tools, Six Sigma tools, problem solving tools. Okay, so we are basically going to the screen is not showing in the center, is it? Okay. Yeah, so what I mean to say is, for every level, some of the part will remain common. So here, wherever it is mentioned green and black belt common, okay, and if you are continuing your study from the green belt to black belt, you can skip this portion. Try to understand this. Okay, just for the new people. Okay, the people who are already been through this, they already are aware about it. All right. Now, wherever there is a common, now look at this. Wherever there is only black belt written in the in the bracket, that is an exclusive black belt content. Understand this? Okay. So you can see here, this is a common one. You can see here, this is also common. Now, if I scroll down, look at this. This is something like exclusive black belt. Okay. Exclusive black belt measurement system analysis. In the green belt level, we have, only introductory part of this. But in the black belt, we go deeper, we go practical, we go a little statistical as well. Okay. So today we are going to learn that. Then normality transformation, black belt. Okay. Then process capability, how the black belt will do the process capability, which is process capability of non-normal data, process capability of the six-pack analysis. All these things basically, are coming into the black belt curriculum. Okay. Then in analyze phase, there are some green belt, black belt common subjects and advanced hypothesis. These are the black belt subjects. So in the nutshell, wherever there is a black belt written in the bracket, those only you need to study. If you are continuing the study, all right. So this is where you are. What you can say? This is where you need to understand that. Yeah, what is the challenge raised, G? Can you just type in the chat box quickly? Yeah, is my voice loud and clear? Just give me yes in the chat box. Is my voice loud and clear? Super clear? Okay. Can you just scroll it down, please? Super. Yeah, Raise G, why don't you, yeah, for others, it is absolutely clear. Why don't you log out and log in again? That might help. Okay. Yes. एक बार try करिए, log out करके log in करिए. Yeah, there might be, yeah. Sachin also, you can also try that. There might be some glitch in Zoom. Okay. Anyway, so everybody got the idea. So whichever black belt in the bracket written, you have to study only that much. So green belt, black belt common, you have already studied in the green belt, so need not to again study that. Okay, clear everybody? Just give me yes in the chat box. Yeah, clear hai? Super clear. Now, why this is done? Because sometimes what happens, few people have a break in their green belt and black belt. Okay, lot of you are continuing your study. After yellow belt, you are studying green belt. After green belt, you are studying black belt. After black belt, master black belt. So you are continuing your study, but some of the people are not able to continue. Okay, so there will be break of 6 months, 3 months. So this subject is very volatile, and that is the only reason why we have what you can say, kept this kind of system. Okay, chalo. So let's open the Minitab software. We'll start from Minitab. Everybody just open your Minitab fresh file. We'll start from some Minitab exercises. Okay. Let me stop this. So in the black belt, we'll go deeper. We'll not cover all the green belt stuff. We will only cover the black belt stuff, which requires more detailed analysis. Okay. Chalo. Any Minitab file you can open. I will also open one. So let me open one Minitab file. You also can open this. Okay now? Okay. Good. Yeah, blank file. Yes, absolutely. Just open any Minitab blank file. Now we will start with the descriptive statistics, okay? And for the people who are, yeah. Or let's do one thing. Let me share one file with you, okay? मैं एक फाइल शेयर करता हूं, वो भी डाउनलोड कर लीजिए. Yes, so yes, now this is for everybody. You can just check out the file in the chat. Okay, just click open that file. If you have opened a new file, that is also okay. And if you open this file, also okay. Okay, both options are okay. Clear? Everybody? Yeah, Shantanu have you got Minitab on your laptop right now? So it requires a laptop or a desktop, whatever, with Minitab. If you have that, then only you will be able to open it. If you don't have, then our team will help you to get that, okay? Clear? Everybody open this file. Just type. I'll share the file once again. Okay, मैं एक बार फिर से file share करता हूँ. So here we go. ये देखिए. Now everybody मैंने share किया है this file. The name is process capability normal. Okay. So I'm just opening the file. Look at this. Everybody got this file? It's a common file. Even in the Greenbelt also, we have used it several times. Greenbelt Hackathon on the live sessions maybe. Okay. Or else you can open any blank file. Okay. Any blank file. Okay. Done. So let's do one thing. Let's go to stat, basic statistics, graphical summary. Just click on the graphical summary. Select C1, the column chocolate weight, and say okay. Everybody has got this? Yes? Just type yes in the chat box if you've got this. Just give me a big yes. Super. Okay. Now, understand this. What is this? So, what is this graph called as? Type in the chat box, everybody. What is this graph called as? Simple. Everybody should understand this, even the new people. Everybody? It's histogram. Yes? Absolutely right. So, histogram meaning, so there are two words in here. Histo is historical, gram meaning graph. So it's a graphical representation of historical data. It's called histogram. Histogram, okay? Which is showing the distribution of the data. Okay. And this is a normal distribution curve. Can you see here? Normal distribution curve. Here. So this is normal distribution curve. Now let's look at this right-hand side statistics over here. The first one says Anderson-Darling normality test. Now, this is a normality test invented by two statisticians, Theodore Anderson and Donald Darling. This one. Okay. Right? So basically what it says is, if the p-value is greater than 0.05, make a note of this. Everybody should be aware of this. This is just a revision we are doing. If the p-value is greater than 0.05, the data is considered to be a normal distributed. Data is considered to be a normal distributed data. Are you clear? So in this case, it is greater than 0.05. So this data, we can call it as normally distributed. So our histogram also is suggesting normality, which is symmetrical distribution. Okay. And, you know, the tails are extended on the both sides. Yeah. So what we are saying here is, so have you got the file, Mr. Mohinder? If you have got the file, which I've shared in the chat. Okay, so this is the file which we shared in the chat. You can just open, yeah. Okay, if you have the file, just open that file and go to stat basic statistics graphical summary. Just click on graphical summary. In the variable, just select the chocolate weight column and just say okay. And you will get this graph and this statistical data in front of you. Now, what we are saying here, the first one is, okay, whether the data is normally distributed. So what do you mean by normal distributed? Let's say this is normal distributed data, symmetrical. If the data is not normally distributed, it will look like this. Are you understanding? Or it might look like this. These are called skewed data. The data in the center, the bell-shaped curve in the center, it is normally distributed data. Data on the left-hand side here and the right-hand side, these are called skewed data. Now, how do we come to know whether the data is normally distributed or skewed? The first indicator is the histogram. So first we can draw histogram, put the data in the histogram, and once we make the histogram, if histogram will tell us some kind of abnormality is there or not. Are you understanding? So if some kind of abnormality is there, meaning the normality is not being seen, then we go for the Anderson-Darling normality test. Okay, and we check the p-value. If the p-value is greater than 0.05, okay, so tomorrow we are going to go deeper into this p-value. What is this p-value? How you can calculate manually this p-value? Everything we are going to discuss tomorrow. Okay. But p-value, which is a probability value, P stands for probability. Okay, so probability value greater than 0.05, that means the data is normal distributed. Clear? Everybody till here with me, just type yes in the chat box. यहां तक सब कुछ मेरे पास मेरे साथ है. Everybody? Yeah, Mohinder ji, are you clear till now? Yes, fantastic, super. So here then, what are the next part? The mean is the average. Standard deviation, which is measuring the variability of the process, standard deviation. Variance, which is standard deviation square. If you take the square of this, it will be variance, or some people call it as variance. Both are same thing, right? It's a little difference in the pronunciation. Okay. Then skewness. What is skewness? Skewness meaning, that's what we said. Let's say if the skewness is 0.000, that is a perfect normal distribution. There is no skewness. Are you understanding? So even though this data is normally distributed, there is a slight skewness over here. But that is very minuscule skewness. Are you understanding? Okay. And kurtosis. What is kurtosis? Kurtosis is nothing but, look at this. So kurtosis is, for example, understand this. All these three distributions are normal distribution, but all in these three distributions, data distributions, you can see the first one is a flatter curve. When the distribution is flatter, the kurtosis is a little negative. Okay. When the what I can say, the distribution becomes very thin, very close to the center, and it is picked. It is very picked. Okay. So kurtosis basically shows the pickedness. So as it goes, it comes in the center, the pick goes up and it becomes positive kurtosis. And there's a formula to calculate kurtosis. All right. So skewness shows how much data is skewed. Perfect normal distribution will be 0.00. And kurtosis negative shows a little flatter curve. In this case, you can see a little negative, kurtosis. And if the distribution becomes closer, that means the standard deviation will reduce. The kurtosis will become positive. If, let's say, if it happens to be like this, okay, then kurtosis will become positive. Okay. Then comes n is equal to 120, which is the number of data points available in the data set. Are you clear till now? Just type yes in the chat box. Everybody is clear? Just give me yes in the chat box. Super clear? Very good. Very good. Amazing. Okay. Now the next part is, okay, now how many of you attended yesterday's box plot wala session? Just type me in the chat box. How many of you attended? कल कौन-कौन थे live session में box plot जो हम लोगों ने cover किया था? Where we covered the basic statistics, which is mean, mode, median, right? So here also the same thing. All right. So the people in the black belt level, what should we take average data points as n represents 120 year? Means 4 months data. No, it's n is equal to 20. For example, it's, you can see here. So if you see the data, if you scroll down, there are 120 data points. Can you see here? There are 120 data points. That's it. N is equal to 120 is number of data points in the sheet. That's it. Okay. So it may be daily data. It may be it may be per shift data. It doesn't matter. We don't know. There are chocolates. 120 chocolate weights we have taken. That's it. Okay. Yes. Now coming back to this. Okay. So here the maximum value of the data set is 38.2. First quartile is 40.8. Now you can see here the box plot. Okay. So this is the lowest value, which is 38.2. The first quartile is 40.8, which is this. Okay. The median is 42.1. This is the median. Okay. Third quartile is 43.250, which is this one is the third quartile. So this is Q1. This is Q2, quartile 2 or median. And this is Q3. And this is the maximum value, which is 46.500. Clear, everybody? And this is called a box plot, which actually we had a complete 1 hour, more than 1 hour session yesterday evening. If a lot of people remember this. Yes? Amazing, amazing. Super. Now, then comes 95%. Now, this is called descriptive statistics. Descriptive statistics. Okay. So my Taylor pen is not working, so I'm just using my mouse. Yesterday also you saw that challenge. Okay. So this is called descriptive statistics. And this portion, it's called inferential statistics. What is inferential? Now with this data of 120 data points, inferential, we are inferring out of this, inferring about the population. This is called inferential statistics. Clear, everybody? So descriptive and inferential are the two parts of the statistics. So statistics can be divided into descriptive. What is descriptive? Descriptive is what is about the sample what we have taken. And inferential is about the population. So what we are saying here is, if the mean of the data, look at here. If the mean of the data is 42.106 of the sample, this is the sample mean. Okay. So the population mean, if this continues, this process continues for a very long time, a long run process is a population, the 95% confidence interval of mean, what does it mean? It means that with 95% confidence, we can say that the mean of the population will lie between 41.808 and 42.403. It is called inferential statistics. We are inferring about the population. Are you clear? Everybody with me till now? Same goes with median. Now, median is 42.1. You can see here. What we are saying here, with 95% confidence, the median of the population will lie between 41.58 to 42.32. And same goes with the standard deviation. So this is called, we are inferring the behavior of the population. Is it clear? Just type yes in the chat box. Super clear hai? Everybody? Very good. Amazing. So this is called descriptive and inferential statistics. All right? Correct? So with this, we will come back to this file again when we will learn about six-pack process capability analysis. Okay, so we are going to learn about six-pack process capability analysis as well today. Okay, so we are going to come back to this file once again, where we will conduct this six-pack process capability in one shot. Okay, now we will cover one topic which is called measurement system analysis, MSA. Make a note of this. Very, very important. Measurement system analysis. So let me just share my screen, share my this one whiteboard with you. Now, because I don't have the what you can say, the writing pen with me, which is not functioning today because of some reason. Okay, so tomorrow I might get a new one. So this is MSA. MSA stands for Measurement System Analysis. Okay. Now, in the green belt level, we cover the basic measurement system analysis, the overview of MSA. Now, in the black belt level, we will go deeper into the measurement system analysis. Okay. Now, in measurement system, how many of you have studied MSA before? Just type me in the chat box. Gauge repeatability, reproducibility, and attribute agreement analysis. How many of you have studied this? Just type me in the chat box. Kisne ye padha hai? How many of you have seen this? Super. Okay, so GB level में हम लोगों ने पढ़ा है. That was a very overview level kind of a thing. Okay. So in GB level, whatever we have covered was in MSA, if we have continuous data, right, then we go for gauge repeatability and reproducibility, GRR. And if we have discrete data, now I hope everybody is clear about what is continuous and what is discrete data. Okay. So in case of discrete data, we go for attribute agreement analysis, AAA. So we are going to see both these aspects of gauge R&R, repeatability and reproducibility, in a practical way, how practically it is possible. Okay. So just for our understanding, GRR, okay, repeatability meaning, so there is, basically this MSA, there are some global guidelines which are followed. Okay. And there's a body called AIAG. Make a note of this, AIAG, which is basically Automotive Industry Action Group, AIAG. This is the body which basically publishes all the global standards requirements for the measurement system analysis. Okay. So AIAG, Automotive Industries Action Group. And according to them, for repeatability and reproducibility and even AAA analysis, you should consider 10 samples. Okay. And every sample has to be tested, and there has to be 3 quality checking person, QC people, or 3 appraisers, we can say. So 3 appraisers, or the people who are the checkers, basically, quality checkers. Okay. And every time, every sample has to be checked 3 times. So there will be 3 trials. Okay. So these are the ground rules, and all the, what I can say, all the equipments, etc., have to be basically calibrated before conducting GRR study. Okay. So 10 sample into 3 appraisals into 3 trials is equal to 90 samples we will get. All right. Yes. So at least 90 data points you should have to conduct a very good gauge R and R study. So these are certain general guidelines which we have already studied in our green belt curriculum. Now, how do we create a worksheet to collect the data? That is what something which we are going to learn today. ठीक है? So GRR के लिए worksheet कैसे create करना है? Just open any new Minitab worksheet. Open any new Minitab worksheet, or the same worksheet also you can open. Okay, the same worksheet, we will create a new GRR worksheet को कैसे create करना है? That is what we are going to learn here. How to create gauge R and R worksheet to collect the data. Okay. So how do we go about it? Open any worksheet, any fresh blank worksheet of the Minitab, or the same one which we have just opened. We can use that as well. Okay. So once we have this, then you go to Stat, Quality Tools, Gauge Study, and create Gauge R&R Study worksheet. All right, just follow this path. Stat, Quality Tools, Gauge Study, Gauge R&R Study worksheet. Once you have done that, everybody with me, just give me a confirmation in the chat quickly. Yeah, just give me the confirmation. Super. Okay, so click on this worksheet. So this will open. Okay, so number of parts are 10. Number of operators, which are the appraisers, are 3. And number of replicates are 2. What do you mean by replicate? Replicate meaning the software is suggesting, okay, to take the repeat reading of the same sample. So here, instead of 2 replicate, we will increase. So replicate is nothing but the trials. Okay. Clear, everybody? So number of parts meaning number of samples. For example, what is number of parts? Imagine this is a pen. I want to measure diameter of the pen. So I have to take 10 pens like this. Okay. And there are 3 operators. Let's say Dhiresh is one operator, Suresh is one operator, and Nilesh is one operator. Imagine these are the 3 operators. So Dhiresh will check once. Okay. Then Suresh will check. Then Nilesh will check. Okay. Again, for the same sample, Dhiresh will check. So Dhiresh will take the reading 3 times. Suresh will take the reading 3 times. Nilesh will take the reading 3 times. Are you understanding? So every person will take every sample 3 times and record the readings. Clear? So sample meaning the parts, meaning the samples. Okay, the pen, in this case, the pen is the part. So there will be 10 pens and 3 people, and every person will take the trial 3 times, and that is called the replicate. Are you clear? Are you with me till now? Just type yes in the chat box. Super clear hai? It is assumed before conducting this study, the calibration has to be done. Okay. It is assumed that the calibration is already done. Okay. Now what happens is the part numbers are here. Now you can give the operator name as I suggested. Let's say Dhiresh, and then Suresh. You can give any name. Okay. And Nilesh. All right. Then let me see in options, anything else? Yeah, as of now, ideally speaking, if you click on option, it says randomize runs within the operator. Of course, it has to be randomized. The runs has to be randomized, no doubt about it, because people should not get to know that this is sample number one, sample number two. Otherwise, there will be some bias which will creep in. Okay. So to avoid that, we need to randomize our runs. Okay. First, maybe second pane will be given, then the seventh pane has to be given, then ninth pane has to be. So there has to be a randomized order. Okay. And software will give you that randomized order, and accordingly, you need to collect the data. Okay. So as of now, we will just say do not randomize. As of now, we will say do not randomize. Okay. And say okay and say okay. Wow, look at this. So here, now try to understand this. So I have not randomized the order. That's why it is coming like part 111. So Dhiresh will check. So here, I will write down diameter. Okay. So here I will check the diameter. Let's say 10.1. All right. Then Suresh will check. It will be 10.1 again. Then maybe Nilesh will check 10.2, whatever it is, right? Then again, part number 2, Dhiresh will check 10.3. Suresh will check 10.3. Nilesh also will check 10.3, etc. Okay. And then similarly, all the, what you can say, 90 readings you have to collect and put it in the data sheet. So these are the 90 readings. Are you clear how to collect the data? Just type yes in the chat box. This is the worksheet we need to follow. This is the worksheet we need to follow. Okay. Now let's do one thing. Let's randomize it. Okay. Let's randomize it. Randomize it. Okay. Go back to the same, dialog box, edit last dialog. You have to just click on Control E or just click on this button. Okay. Click on this button or just say Control E. Just click Control E. Okay. Now let's try something. If you have Dhiresh, Suresh, Nilesh, let's just for the sake of this, just put the operator name Dhiresh, Suresh, and Nilesh. Everybody, just do this. Let's try one experiment here. Everybody, just try one experiment here. Operator Dhiresh, Suresh, Nilesh. If you have done this, just type done in the chat box. एक experiment करते हैं हम लोग. Done. Okay, just change the name. Okay, go to option now. Okay, go to option now. Now you say randomize all runs. You say randomize all runs. The second option is random. Just click on that and it will say base for random data generator. Base for random data generator. So everybody just put 1, 2, 3. Everybody just put 1, 2, 3. I'm just doing an experiment. Let's see. So now this is the first one we tried. Yeah, I'll repeat. Okay. Yahan tak samajh mein aaya sabko? Okay. So without randomization, we have created this worksheet, correct? Without randomization, we have created this. Now we will connect with randomize. Now you just put the names Dhiresh, Suresh, and Nilesh in the operator name. Go to option, randomize all runs. Just click on randomize all runs. And below this will, base for random data generator will come. Here, you can see my cursor. Okay. Here in the box, just put 1, 2, 3. That's it. Okay. And just say okay. And just say okay. Now, just go back to the worksheet. Now, our entire worksheet has been randomized. How many of you have observed this? Now, are you observing the first part is Dhiresh, part number 2. Second part is part number 4, again Dhiresh, part number 6, again Dhiresh. The fourth one is 2, is Suresh, 5 is Suresh, 5 is Suresh. How many of you are observing this? the same pattern would be common for all the people who have absolutely put the same random data generator. Are you observing the same thing? Just type yes in the chat box. Very good. So what does it mean? It means now we have randomized it. And now let's say, imagine you all are our team members, project team members. So everybody have the same order of the randomized order. So you can conduct the experiment accordingly. So everybody has the same order. Okay. Yes, Alokji, the data, the recording will be available in the hackathon. Yes, hackathon folder mein available hoga, black belt hackathon. Okay. No worries. We have just started the gauge arena. All right. Everybody clear with me? This is how you can create the worksheet for this MSA, measurement system analysis. Okay. Done. Super. Now, after creating this, how do we analyze it? Okay. So let me share one file with you. Let me just share the file with you. Just a second. I'll just explain once again. Okay. Just download this file. Meanwhile, I'll repeat this, this explanation once again. Yeah. So Priyanka, what is this? We have generated. If I go back to the option, we all have put the random data generator number 1, 2, 3. Yes. We all have put this random data generator 1, 2, 3. Yes or no? Right? Now, once we put random data generator 1, 2, 3, all the people who have put 1, 2, 3, the software will randomize it. But because there is a common data generator key we have put, everybody's randomized pattern will be exactly same. Have you got this? Everybody's randomized pattern will be exactly same. That means, let's say, for example, if I don't have this 1, 2, 3, if I don't put 1, 2, 3, and if I randomize all runs, okay, everybody would have their different pattern. So now it is Dinesh, this might be Suresh. Okay, this might be Nilesh, this might be, so the pattern of randomization will be different. So by keeping this standard randomized base 1, 2, 3, or any number you can put, but it should be common, okay, across all the people who are putting this data. Okay, if you put a common number, it will generate a common pattern across all the people. Clear now? Now you can conduct the experiment exactly with the same sequence. Everybody will be on the same page with the same sequence. So there will not be any misplacement. Okay, clear? Very good, super. Okay, now just open the file which I have just shared. So open the file which I have just shared with you. So the file says the similar kind of one. Only thing is that the operators name have changed from Vijay, Yogesh, and Manish. Okay. So we have got 90 data points with some length they have measured in mm. Okay. Length or diameter, whatever it is, right? Size in mm. And these are the operators' name. Here, everybody open this. So we have understood how to create the file. Now we will understand how do we analyze the data. How do we analyze the data? That is something which we are going to learn. Okay. Yes, open. So go to stat, go to quality tools, gauge study, and we have to select GRR crossed. Gauge R and R crossed. Everybody select crossed. What is crossed basically? Understand this. Okay, just a second. Now crossed meaning, so there are 3 operators, right? 1, 2, and 3. And there are 10 samples. 1, 2, 3, 4, 5, 6, 7. These are the samples. So this operator, everybody is checking each and every sample. Like this. Okay. Now this one also is checking. This one is also checking. And this is called the crossed way of checking. This is called the crossed way of checking. That's why it is called cross. There is something called destructive testing. How many of you know destructive testing? Just type me in the chat box. How many of you know destructive testing? In the quality, there is something called destructive testing. Yes, how many of you know that? How many of you are aware of destructive testing of quality? What is destructive? Let's say, for example, tensile strength. Okay, tensile strength. If I want to check, I will put that bar or the plate to the tensile strength machine, and it will pull that bar or that that article till the time it elongates. So it gets deformed. Okay, it breaks basically. Correct? It breaks. And that is where it gets destroyed. The sample gets destroyed. That is called destructive testing. Yes. So you have to study till the destruction. In automotive also, there are a lot of destructive testing. Accident के testing करते हैं ना वो shock absorbers and accident वाला testing है. So that is called all destructive testing, right? Now, in the destructive testing, you cannot use the same sample cannot be used, right? Right? So that is called, so in that case, that is called as what? So I will explain you again. Go to quality tools, gauge study. So that is called nested study. Whenever you are using destructive testing, it is called nested study. And expanded study meaning whenever you are now, let's say, for example, you are using just one parameter called diameter. Okay. If you are measuring multiple parameters, okay, multiple factors, all right. So you can see expanded, right? So right now we are studying the crossed one. Just select crossed. Just put पार्ट नंबर में सैंपल सिलेक्ट करो, ऑपरेटर्स में ऑपरेटर सिलेक्ट करो एंड मेजरमेंट डेटा में साइज सिलेक्ट करो. एवरीबॉडी yes, so part study, part number, sample, operators in operator and measurement data size. Okay, everybody selects this. So by default it is X bar and R and ANOVA, both you can use basically. So let's use X bar R as of now. Go to option and just put upper specification and lower specification minus lower specification is equal to 1. Just put 1 over here. Okay. Yeah, I'll repeat the path once again. The path is stat quality tools gauge study crossed. So first what we did, we created a worksheet where we can conduct the experiment and collect the data. Once the data is collected, now we are not able to collect the data. That's why I've given you a ready-made data. All right. Yes. So, somebody from the YouTube. So there is no basics of this 1, 2, 3. Okay, Mr. Tirupati. It is, you can put 1, 2, 3, 4 or 0, 1, 2, 3, whatever it is, but it should be common number. That is the reason. Okay. Yeah. Coming back to the crossed. If you click on cross, then put all the numbers, the sample and the operator and the size in the measure data. Go to option and upper and lower specification difference is 1. What does it mean? What does it mean? It means, let's say this is the data. If you have corrected the data, okay, between the lower specification limit and upper specification limit. So LSL and USL, this difference is 1 mm. This difference is 1 mm. That's what we are saying. 1 mm. Okay, because we are conducting in collecting the data in mm. Okay, so it is 1 mm difference between LSL and USL. That's what we are putting over here. Okay, coming back to this, I'm going to the option and putting USL LSL is equal to 1. Okay, say okay and say okay. And look at this. Everybody got this? Just type yes in the chat box. Everybody got this? Just type yes. Super. Now let's try to understand the graph first, and then we will understand the statistical, what you can say, the analysis. Okay. First graphical, and then we'll go for the statistical. Okay. Finally. Okay. So look at this. Okay. So here, understand this. There is gauge R&R, and there is part-to-part variation. First, try to understand the meaning of this. What is part-to-part variation? Part-to-part variation meaning the actual variation between the readings. And what is gauge R&R variation? Gauge R&R is out of this total variation, how much is because of the measurement system, the equipment, and the person. Just understand this. Just understand this. Okay. How much is the actual variation? Let's say, for example, one pen is 2.5, second pen is 2.6, third pen is, let's say, 2.7. Okay. Then again 2.4. Now the difference, the maximum is 2.7 and the lowest is 2.4. So there is actually the difference is, the total difference is, let's say, 0.3. I'm just giving you so that you can imagine this. Okay, just try to understand this. The total difference, the variation, let's say, I'm just taking the range right now, is 0.3. This is the total variation, out of which, now understand this, while measuring also, there might be some 19 bees, there might be some kind of error. Are you understanding? How much is that error of this 0.3 is a total variation? If I plot the total variation like this, okay, then at least 10% would be because of some measurement error. Measurement error. Are you understanding? And that measurement error is this part, gauge R&R. And what is the remaining? The actual part to part is this one. So idealistically speaking, the part to part variation graph should always be higher than gauge R&R. That is what is the desirable state. Clear, everybody? Just type yes in the chat box. So ideally, part to part has always to be greater than your gauge R&R number. Gauge R&R is repeatability and reproducibility. So this is repeatability, this is reproducibility, and if you add them up, this becomes gauge R&R. Okay, so this is absolutely up to the mark for us. Okay, now this is called X bar and R chart, one of the control chart. Okay, everybody is aware of the control chart, yes or no? The stability control chart, yes or no? Everybody is aware, simple control chart, correct? Now X bar R chart is also one of the control chart we are using here. Now here, only difference is that the control limits are calculated separately. There are the special control limits. In this part, now, if you remember the basics of control chart, for the new people especially, okay? So if the process is between, plus and minus 3 standard deviation, this is upper control limit, and this is lower control limit, which is generally plus and minus 3 standard, and this is the X bar, the average. Okay. Now, if the process is flowing between control limits, that process is said to be a stable process. That's what we have learned. Here, it is something different. Okay, here, what we are expecting is for the range chart, this fundamental will be absolutely applicable. The data should be absolutely between the control limits. It should be between the control limits. Then it's a good sign. Okay. So only this data is having some challenge. Can you see Vijay? This reading of Vijay, we should investigate because there is some more range. Okay. This is R meaning the range chart. Okay, whatever 3 readings they have taken, no? What is the maximum reading? What is the minimum reading? What is the difference between these 3? That is called the range. So all the differences are plotted here. So it should be between that red line of control limit. That is a normal scenario. But over here in the X bar chart, it is exactly opposite. It is expected that the minimum number of data points should be within the control limits and maximum number of data points should be outside of the control limit. Then it is a desirable condition. How many of you got this? So the control limits are basically plotted very close. Okay. And these formulae are completely different than our traditional +3 -3 standard deviation formula. Okay. They're different formulae, but what we need to check that very less number of data points should be within the band of that red, the upper and lower control, and maximum number of data points should be outside of the control limits. So, जो outside of the control limits है ना, they are representing part-to-part variation, and the data points which are within the control limits, they are representing gauge R and R. What is desirable? Less number of data points should be within control limits. Are you clear? Just type yes in the chat box. Clear, ham, everybody? Just type yes. Super clear? Just give me confirmation. Amazing, amazing. Just keep giving me confirmation so that I can understand that you guys are following this, okay? Yeah. See, only thing is that for the X bar chart, what changes here is the desirable condition. So X bar chart looks like this, okay? This is the center line. Of course, I'm just drawing with my what you can say, mouse to, I'm not able to draw this straight line, okay? So if the data is like this, okay, so only this point is here, okay, and remaining all data points are, maybe this point is inside the control limits, okay, only couple of points are in the control limits, rest all the data points are beyond control limits, and this is what is the actual expected what you can say condition, okay. Okay, so in this case, X bar R chart may, okay, no, this is range. X bar is average and R is range. Okay. X bar represents average of the part to part or the measured data basically. And R basically, so this is how, for example, let's say Manish, example. Okay. Manish ka example lete hain. So this is Manish's 10 samples. Can you see here? Manish's 10 samples. Okay. So let's say sample number 1. How do you plot sample number 1 of Manish? Manish has taken 3 readings. 10.1, 10.1 and 10.0. So what is the range? Maximum minus minimum. So 10.1 minus 10.0. So the range will be 0.1. For the first sample, Manish's range will be 0.1. So we will plot 0.1 over here. Clear? This is the first data point. Then we will see Manish's second samples reading. All the 3 samples. So we will take the range of the maximum and the minimum and we will plot accordingly. This is called the range chart. Clear hai? Range chart clear, everybody? I am talking about this chart. Okay. Now, similarly, X bar. Whatever 3 readings Manish has taken, I will take the average of that reading and I will plot accordingly. Now, for example, look at this Manish's reading. The first data point is around 2.6. Okay, 2.6. So, Manish's first 3 readings, average will be 2.6. So, I will plot 2.6 here. Then second readings, Manish's second reading is 2.3. So, I will plot 2.3 over here. Okay, so, and I will keep on plotting the averages of all the reading. Okay, clear here? Super. Amazing. So, these are the sum of the graphical representation. Now, this is how the sample in mm. Okay, so these are all the data points plotted. Okay, and the average is plotted over there. So all the data points. That means for all the samples, okay, for every sample we have taken 30 readings, right? for every sample, we have taken, sorry, 9 readings, 9. Everybody has taken 3 readings. So for every pen, let's say diameter is taken. So for every pen, 9 readings. So these are all 9 readings plotted here. Okay. And this is called the box plot, which we have studied yesterday. Okay. And this is the, the Manish is blue, Vijay is red, and Yogesh is green. So they have plotted individual samples against each other. So sample into operator interaction. So this is called a graphical representation, but the major part lies in the statistical representation. Okay, let's open here. Let's go to the statistical explanation of this. Just click on this button, which is called the sessions folder. Just click on the sessions folder. Yeah. So if you click on this, second, yeah. If you can click on the sessions folder here, this button, okay. The short form is Control Alt M. Control Alt M. It is the sessions folder ka short key. Okay. To click on that and just scroll it up. Scroll it up. Okay. Look at this. So this is where we have seen gauge R&R X bar R study, what we are doing. Okay. So right now there are 3 parts we need to check. To check whether our GRR study is perfectly under the, what I can say, under the norm as or not. Okay. The first one is this one. Look at this. This contribution, GRR contribution is 2.36. So part to part contribution is 97.64 out of 100. So let's say variation is 100%. The part to part, actual part to part variation is 97.64%, and the gauge R&R contribution is 2.36%. If it is less than 10%, it is acceptable. Okay, in this case, it is less than 10%. So it is acceptable. Okay. Then comes the second one is, you can see here, against the tolerance. So percentage tolerance. All right. So the percentage tolerance should be again less than 10%. In this case, it is 8.41. So again, it should be less than 10%. So both these cases. Okay. So percentage contribution and percentage tolerance of GRR should be less than 10%. It should be the gauge is acceptable. Okay. And the third is number of distinct categories, NDC, is equal to 9. Okay. Whenever NDC is equal to or greater than 5, equal to or greater than 5, in that case, your gauge is pass. So these are the 3 checkpoints we need to check. Percentage contribution greater than, less than 10. This one, it should be less than 10%. Then percentage tolerance should be less than 10%, and NDC should be equal or greater than 5. If you meet these 3 criteria, that means our gauge R&R study is successful. If it does not meet this criteria, then we need to check which parameter is failing, which appraisal is giving more variation. We need to do the brainstorming, identify the causes, recalibrate the system, give some training to the operator, and conduct the study again till the time we get our numbers below 10% and NDC 5, greater than 5. Clear, everybody? This is called how do we conduct gauge R&R study, in detail, right from the creating the, worksheet, conducting the study, and analyzing the study in details. Just type yes in the chat box if you have understood this. Have you understood how to conduct the procedure step by step? Yes? Fantastic, fantastic, super. The last column, this NDC wala column you are saying? Yeah. So study variance divided by tolerance. What is study variance? Study variance is this. Okay, percentage study variance. What is so? See, there are what you can say. So standard deviation is calculated, which is sigma. Okay. Then study variance meaning 6 into standard. So you multiply this value into 6. That becomes the percentage study variance. And what happens is, you basically you have taken the tolerance 1 mm, if you remember. Okay. So against the tolerance, how much is your study variance against the tolerance? So tolerance, study variance divided by tolerance is equal to percentage, and into 100, of course, into 100 is equal to percentage tolerance. And that percentage tolerance should be less than 10%. In short, let's make this very simple. This is the total variation. Your gauge R&R variation should be less than 10%, this much. That's what it means. Clear? Is it clear with this? Just type yes in the chat box. Clear hai? Okay. Now coming back to NDC. What is NDC in the layman's language? NDC is number of distinct categories. Okay. Let's say, for example, if you have a gauge which says low pressure and high pressure, in that case, NDC is equal to 2. NDC is equal to 2. If you have the gauge which says low, medium, and high, NDC is equal to 3. So there are 3 distinct categories you can actually measure the data. If let's say your measurement is having extremely low, medium, extremely low, medium, high, extremely high. That means my NDC is 5. So there are 5 categories I can measure with my measuring scale. So at least 5 or more is a good scale, measuring scale. Clear, everybody? Just type yes in the chat box. Super clear? See, what I will do is I will conduct, ANOVA table and this gauge R&R table के लिए separately हम लोग एक class लेंगे. Okay, so every data we will calculate manually as well. Okay, there are formula to calculate. But just we need to understand overall variation. It should be 10% of the overall variation. The measurement should be 10% contributing. So we are quantifying the contribution of the measurement system into this variation. If it is less than 10, the measurement system is good. If it is contributing 20%, 30% and above, then we have to reject it. Are you understanding? So this is how, because we are depending on the data. If the data which is collected from the measurement system, that measurement system itself is giving a lot of variation. And in Six Sigma, we are reducing the variation, right? So measurement system itself is the source of variation. So we need to basically kill the source of variation there and there itself. And that is the entire objective of this study. Clear now? Yes? Just type yes in the chat box. What I will do is I will conduct a separate, it will take 1.5 hours to explain all the data point. We will manually calculate, okay? Repeatability ka calculate karenge, reproducibility ka calculate karenge, okay? Now I will show you how to do this with the help of GRR, okay? GRR, triple A का करेंगे हम लोग. थोड़ा सा आपको repeatability, reproducibility percentage समझ में आएगा, okay? Now I will just give you triple A का एक file, okay? Just open this file. I'm just giving a triple A file with you. Just now let's look at the triple A file, okay? Let's look at a triple A file. Super. Got it? Once you have opened it, let me know in the chat box. Once you have opened it, just let me know done, done, and done in the chat. All right, let me also open it. Okay, everybody got this file? Just give me yes in the chat box. Okay, try to understand the file first and then we will understand this. Okay, now here, whenever you have continuous data, now continuous data meaning we can measure on the continuous scale like temperature, pressure, height, width. Okay, all this data is called continuous data. Then we will use gauge R and R. But whenever we have attribute agreement analysis, when do we use? When we have discrete data. Okay, yes, okay, not okay, fail, pass, male, female. So there is no continuous measurement, but these are the discrete data points we are collecting. For example, let's see a bank. Okay, there is a bank, and in the bank, the people are checking their files. Okay, let's say loan files, and these are uh, so this is, let's say, sample one. Let's say this is file number one. It is going to the credit department. So officer number one is saying no. That means he's rejecting it. Just try to understand the data. Officer number two, again, he's rejecting. Officer number three also is rejecting. Okay. Again, it goes to officer number B, rejecting. Officer number C also rejecting. And now there is a these are the officers, credit officers, and over and above there is a head of the department or credit manager. He is the standard basically. So his decision will be final. वो जो बोलेंगे वो final decision होगा. Clear? So he is also saying no. He is also rejecting the file. Clear है? Similar in the second file. Okay, so officer A is accepting first trial, accepting the second trial, accepting the third trial. Officer B also accepting in all three trials. Officer C, look at this. Officer C accepts this in the first time, but rejects the file the second time and reject the file the third time as well. Are you understanding the scenario with this data? Just type yes in the chat box. Just type yes in the chat box. Understood? Scenario समझ में आ रहा है? Very good. Super. Super duper. Okay, now try to understand. Now let's try to understand this. Here. So let's try to understand the repeatability and reproducibility. Okay. Now, how do you find the repeatability manually? Manually कैसे calculate करेंगे repeatability को? First, let's focus on officer number A. So just focus on this area. Okay. ऑफिसर नंबर ए का एरिया ये वाला एरिया है. ओके, ठीक है. नाउ द फर्स्ट केस, ओके, ऑफिसर इज सेइंग नो नो नो. दैट मींस ही इज रिपीटेबल मीनिंग ही इज गिविंग द सेम रीडिंग अगेन एंड अगेन. दैट इज कॉल्ड रिपीटेबिलिटी. क्लियर है? द सेम पर्सन गिविंग द सेम रीडिंग अगेन एंड अगेन, इट इज कॉल्ड रिपीटेबिलिटी. And other people are giving the same reading again and again. It's called reproducibility. Are you clear? And how do you remember this? I just remember with a simple formula. Reproducibility required. Now let's say to reproduce, how do I remember? To reproduce, one person cannot reproduce. You require a male and a female to reproduce a baby, right? So we require two people at least to reproduce. That means we need more people to reproduce. So reproducibility meaning more people. So that way you can remember this. A lot of people get confused between how do I remember repeatability and reproducibility. Repeatability meaning the same person repeating the same reading, and reproducibility meaning different people producing the same reading. Clear everybody? Just type yes in the chat box. Clear hand? Just give me yes. Simple, एकदम simple formula मैंने दिया है. Okay. Now coming back to officer A. Now we will calculate the percentage of repeatability of officer A. Okay. Now look at this. Officer A first says no, no, no. Is he repeatable? Is he repeatable? Why screening is bottom, which is not visible? Screening is bottom. Screening in bottom, not visible, is it? Is the screen visible, guys, to you? Everything, the screen is visible? Okay, okay. एक बार वसुदेव जी एक बार चेक करिए, आपके इधर से मे बी कुछ एडजस्टमेंट होगा. Maybe you can just what you can say, switch off, log out and log in. That might help. Yeah. Now coming back to this one. Okay, let's focus on officer A only. Let's focus on officer A. So no, no, no meaning is repeatable. The second one is saying yes, 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 he's repeatable. Yes. Okay. The third one is no, 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 he's repeatable. Okay. Fourth one also yes, 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 repeatable. Fifth one yes, yes, yes. Sixth one no, no, no. Seventh no, no, no. Eighth no, no, no. Ninth yes, yes, yes. And 10th no, no, no. So he is 100% repeatable. How many of you got it? How many of you got it? Just type yes in the chat box. Everybody got it? He is 100% repeatable. Clear? Now, can you just check for officer number B and type in the chat box? What is the percentage repeatability of officer number B? Check officer number B. Now, for officer number B, you have to just check these three. Okay? Can you check officer number B's percentage, everybody? Very good. 90%. Everybody got it? Only the last one is failing. Can you see here? This one, last one. He says yes, yes, and no. So 90% repeatability. Can you check their officer number C's repeatability? Officer number C's repeatability, can you just check? %. Everybody got the 80%? So you can see the reading number 9 is failing and the reading number 2 is failing. Can you see? Otherwise, all the 8 readings are absolutely perfect. Clear? How to calculate repeatability manually? Have you understood this? 100%, 90%, 80%. Clear? Now let's calculate the reproducibility manually. ठीक है, आपको अंदाजा आ जाएगा. Reproducibility को manually calculate करेंगे. How do you calculate manually reproducibility? So let's remove this first. Now just observe sample number 1 across. Look at this. So just observe this line. No, 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 and no. Everybody is saying no. So this is completely reproducible. So this is okay, reproducibility. Okay. Second one, can you just check the second one? Second one is failing the reproducibility because officer number C is saying no, no. Even one no, or even one, see, if everybody is saying no and even one says yes, that means the reproducibility is failed. Clear hai? Okay. So the second one has failed. The third one has also failed. The fourth one is okay. The fifth one is okay. The sixth one is okay. The seventh one is okay. The eighth one is also okay. The ninth one is failing. And the 10th one is also failing. That means the reproducibility is 60%. How many of you got it? Just type got it in the chat box. How many of you got this? Just type yes in the chat box. Got it 60%? Everybody? Super cool. Fantastic. Fantastic. Amazing. So have you understood how to calculate repeatability and reproducibility manually? Okay. Now we will do the analysis. How to do the analysis of this? Okay. Let's go back to stat, quality tools. Instead of gauge study, it is attribute agreement analysis, AAA. Can you just select AAA here? Stat, quality tools, attribute agreement analysis. Okay. Select that. Click on that. Now, because now here the data is, data is in multiple columns, right? So select this multiple column option, the second one. Okay. And click on this. Click on this. Now understand this. Observe what I'm doing. You need to select column C2 to column C10. Okay. I repeat again. Look at this. So we need to select this much. Column C2 to column C10. These are the 9 columns we need to select. Okay, everybody got it? Yes. So we need to select these 9 columns. So I go back again. I select multiple columns and I select this. I click on shift and I click on C10. Okay, and I click on select. And it will get all selected. I repeat again. I just remove this. I click on C2, column C2, I click on, then I click on shift, and then I click on C10, okay? And then I click on select. It will get all selected, okay? Then number of appraisals are 3 appraisals, number of trials are 3, and appraisal names are optional. If you want to give, you can give. If you don't want to give, you can skip it, okay? Then attribute, the known standard is the truth, okay? So click here and select the truth column. Truth is the manager's reading, okay? So select truth. And let me check. Rest, everything should be okay, fine. Just say okay. And this graph will appear. How many of you got this graph? Just type me in the chat box. Got the graph? Everybody? Just give me yes. Super, super. Now try to understand this. This is within appraisers, which is nothing but reproducibility. And this is accuracy of reproducibility. What does it mean? You remember we calculated, repeatability. Okay, this is repeatability within appraiser. So the first one was 100%. Okay. The second one was 90%. Third one was 80%. Do you remember this? Just give me yes in the chat box. Yes. 100, 90, 80% manually हम लोगों ने calculate किया था. So the software is showing this. And what are these ranges? This is nothing but 95% confidence interval, the same thing which we studied in our, the graphical statistical analysis. Okay, with 95% confidence, we are saying that, okay, the repeatability in future, in the longer run, the repeatability of operator number 1 will be around 75 to 100%. Repeatability of operator number 2 will be around 55 to 100%. And repeatability of operator number 3 will be around 45 to 95%. And there are formula to calculate this. Okay. Here, the most important part are the blue dots, which were manually calculated, 100, 90, and 80. Okay. And now this is the appraisal versus the standard. Okay. What does it mean? It means 100% of the time, okay, appraiser with the standard, they were actually agreeing with each other. So first person and the standard, which is the manager of the department, 100% agreeing with appraiser number 1, 80% of the time agreement with appraiser number 2, and 80% time with appraiser number 3. So that means it is a clear-cut indication that appraiser number 1 is very much accurate, precise. Okay, so appraiser number 2 and 3 require some kind of training from appraiser number 1. Are you clear with this? Just type yes in the chat box. Clear hai? Super. Now look at this. Just click on the click on this statistical sessions folder. If you click on the sessions folder, you will come to the sessions window. Okay, just scroll it up. Just scroll it up, scroll it up, scroll it up. There are a lot of numbers, lot of data points, but let's not get bogged down with this. Okay, what is most important is this. So this is attribute agreement analysis. Okay, so 10 samples everybody has inspected. Now, what is the percentage of repeatability, which was 100%? For second, it is 90%. For the third, it was 80%. Clear this one? Yeah, 95% confidence interval is, it is a standard value selected by the statistician, 95% confidence level. Okay. So tomorrow, when we are going to study about confidence level, confidence and what you can say, there is called significance level, the p-value, hypothesis testing, I will touch upon this part. Okay. There is something to do with sampling and a population, sample and a population proportion. Okay. So 95% is a standard number which statisticians are basically considered. Okay. Yeah. Now coming back to this. Now there we had, what are the values in brackets? These are the same values which were there. Okay. Let's say, for example, 174.11. Okay. So this is what, if I go back to the, if I go back to the graph, okay, can you see 100 here? This is 100 and this is 74.1. Are you understanding? In the second bracket, it is 100 and something around 50. Okay, that is what that bracket is. Okay, clear? Very good, very good. Super. Chalo. Now, then going back again. Here, there we had the GRR score, right? In this case, okay. Yeah, because the calculation of 95% confidence interval here is a different formula. It's a different formula. According to the behavior of the part, the second appraisal, it is showing that 95% confidence, it is, this much. Are you clear? Yes. Now, coming back to this, there we used to calculate the GRR score. Here we are calculating the, what you can say, kappa value, Fleece kappa value. Again, Fleece kappa is the name of the statistician. On his name, the, the kappa, what you can say, statistics is basically discovered. Okay. Now, here you can see the kappa value here is 1. When your repeatability percentage was 100, kappa value is 1. 1 means the best kappa value. Okay. When your repeatability percentage reduces, it is reflected in the kappa value. When it is 90%, it is 0.86. When it is 80%, it is 0.65. Are you clear? So kappa value also is reflected. Again, the kappa value, there is a formula to calculate the kappa value. Okay. Now we need not to calculate it manually because there is a huge formula calculation required. We need not to go into the details of it. What we need to check is this kappa value at the end of it. Okay, look at this. This is the Fleece kappa value. This should be, okay, now write this down. If it is between 1 to 0.9, it is the best measurement system. Okay. If it is between 0.9 to 0.7, okay, still needs improvement. So needs improvement. I'm just writing. Please try to understand my challenge. Okay. And if it is less than 0.7, then we can reject the scale. Okay. Now, in this case, it is 0.7. It is very close to 0.8. So needs improvement. Where do we need improvement? In appraisal number 2 and appraisal number 3, we require some improvement. We require some training, coaching, understanding. Okay. So that the kappa value, overall kappa value should be more than 0.9. Are you clear? So this is what we need to basically check in the attribute agreement analysis. Rest everything remains absolutely similar to your gauge R&R. Clear, everybody? Just type yes in the chat box. Super clear? Okay. Now we are at 8:34. We will just take a quick 6 minutes break. Okay, just a bio break. Maybe you want to have a cup of coffee or a tea. You can just grab it. Okay. And we will back exactly at 8:40. Okay. Yes. You want more than 6 minutes? Let's take 10 minutes. Chalo, 10 minutes le lete. Let's come back 8:45. ठीक है 8:45 को आ जाते हैं. ठीक है गुड इनफ. चलो 8:45. We'll be back at 8:45. Once you are back, just type I'm back in the chat box. Okay, once you are back. ठीक है. Super. Thank you very much. Okay, everybody just type I am back in the chat box so that we can start again the second half of our session. Everybody just type I am back. Just give me the confirmation. Super. I'm back. Amazing, amazing. You guys are awesome. Now uh, let's talk about the six-pack analysis. Okay. What is six-pack analysis? Can you just open the same chocolate wala file? The same file which we used for the descriptive statistics. Correct? Do you have that file with you? Or shall I give it back to you again? Okay, so look, मैं एक बार फिर से दे देता हूं. Open this file and we will check normality, capability, stability, normality, capability. Okay, SNC. SNC को करेंगे अभी पहले. What is stability, what is normality, what is capability? Okay. So open this file. Once you open the file, the same file of chocolate weight which we have just used for the descriptive statistics. Okay, the first file which we opened. Okay, so I'm just referring to the same file. Yeah, once you have opened it, let me know in the chat box. Well, let me just close all the files which I've opened. Yes, open, guys. All right. Chalo. So, what is the most important part here? The most important part here is, let me just share my screen. Okay, so everybody knows about the S, N, and C. Just type yes in the chat box. Everybody's aware of S and C, especially the people who are into the black belt cadre and want to go for the black belt examination this time. SNC is aware. Okay, the new people, you may not be aware of SNC. SNC we do in the major phase. Okay, before we, so C for capability. Okay, before we do the process capability, we just conduct these two processes. What is called S stands for stability, exactly. So stability, S for stability, which is nothing but our control chart, which we have seen earlier, right? It is a stability check, right? Then N for normality. N stands for normality, which is nothing but Anderson-Darling normality test. Okay. And C for capability. Now, before we go for capability, we have to check whether the data is stable and normal. See, stability and normality will increase the probability of actually, what you can say, our predictability. Okay, I always give the example of, if there is a child and the child is very well disciplined. Okay, so the child wakes up at 6 o'clock, gets ready to school at 7 o'clock, reaches school at 7:30, comes back at 1 p.m., studies very hard till 5 p.m., plays for 1 hour. So every day he absolutely follows the same process. He's very predictable. Okay, that is called stability and normality. Now, if you ask the parents that at 1:30 p.m. what that child would be doing, so the parents will be absolutely sure that at 1:30 p.m. he would be studying. Okay, that is called stability and normality of the data. If the stability and normality is not there, the predictability becomes very difficult. That is why stability normality checking is very, very important before we do the capability. Okay, now we will do the stability, normality, and capability separately, and then we will do six-pack analysis where we can do all these three together in one shot. Are you clear? Now, let's do one thing. First, we will do the stability check. How do we do stability check? Go to stat, control chart, individual control chart, individual. Everybody follow the step. Go to stat, go to control chart, variable charts for individual, individual. Follow this. Stat, control chart, variable charts for individual, individual. Okay. Now, if you click on individual, this window will appear. Now you have to be a little faster now, okay? Because you are going to become a black belt certified person. So your speed in this should increase now, okay? Double click on chocolate weight and say, okay. Here we go. Everybody got this? Super. Now, this is said to be a stable process barring only one data point, which is just on the boundary line. Otherwise, the process is more or less stable. Okay, 120 data points, only one point is touching the upper control limit. All right. Yeah, the flow is go to stat, control charts, variable charts for individual, individual. This is a flow. Take a screenshot if you wish, so that it will not screenshot, you can save. Save. Yeah, I'll just share the file once again. Okay, this is the file I've shared. All right. Clear? So any data which is within the control limit, it's a common cause variation. Any data which goes beyond control limit is called special cause variation. So this is called a quick stability check. All right. Now let's go for normality check. How do you go for normality? So stat, basic statistics, normality test. Let's look at this. Stat, basic statistics, normality test. Stat, basic statistics, normality test. All right. Just click on that. Select your chocolate weight in the variable column and just say, okay, that's it. Don't do anything else. Look at this. This is called the normality test. Now, this test we have already done in our descriptive statistics. You remember that? The p-value was 0.256. If the p-value is greater than 0.05, that means the data is normally distributed. Correct? So it is called stability and normality test. Stability. So we have done the stability in the control chart. This is called normality test. And we have already done this in the green belt. I'm just repeating it quickly. Okay? Now we'll go for the process capability. Now, how do we go for the process capability analysis? Now, go to stat, quality tools, capability analysis, normal. Stat, quality tools, capability analysis, normal. All right. Now, just put the single column, which is our chocolate weight. Subgroup size, just put 1. Lower specification limit, just put 36. Upper specification limit, just put 48. I'm just giving some random numbers. You can give because the data is around 42. So I've just taken, 5 to 6 data points on the left-hand side, 5 to 6 data points on the right-hand side. Okay. So 36 and 48 are the lower and upper control limits. Sorry, specification limit. And go to option, select benchmark Z. I repeat entire process once again. Okay, this is the data. This is the data we have. Go to stat, quality tools, capability analysis normal. Stat, quality tools, capability analysis normal. Just select normal. In a single column, select the chocolate weight. Subgroup size, select 1. Lower specification limit, just put 36. Upper specification limit 48 because, and in option, just select benchmark Z and say OK. And say OK. And you will find this analysis. So what we are getting over here is our process capability. The benchmark Z is 3.93. That means our current process is 3.93 sigma process, approximately 4 sigma process. We say na 3 sigma, 4 sigma, 4 sigma, 5 sigma. Okay, so this is 3.93 sigma process. Are you clear? So this Z bench value is something which we are basically checking. Clear hai? Just type yes in the chat box. Super clear, everybody? This is how traditionally, this is the green belt stuff I'm repeating, okay? Now in the black belt, you can do everything in one shot. How you can do that? It is called 6-pack analysis. Go to stat, go to quality tools. Instead of capability analysis, go to capability 6-pack normal. Can you follow this? Stat, quality tools, capability 6-pack normal. Just click on normal and just do the same thing. Chocolate weight, 1. Lower specification is 36. Upper specification is 48. And go to option and select benchmark Z and say OK. And say OK. Wow, look at this. Amit ji, you are not able to see the screen, is it? Can you just, if you are on the mobile phone, maybe just swipe on the other screens. Just check the other screens, you will find. Okay, can you just quickly log out and log in once again? There might be some glitch. All right. Everybody can see the screen, right? Because there are 3 screens in front of me, and all the 3 screens are absolutely showing it clearly. Click on pop out, then screen is shown. Okay. So Sachin ji is suggesting you something. I'm just copying this Sachin ji's what you can say message, and I'm just putting in the chat. Okay. Click on pop out, then screen is shown. Can you just check out that? Okay. एक बार पॉप आउट को क्लिक करिए और एक बार चेक करिएगा. Everybody saying the screen is visible and very much clear. Just check out, कुछ तो glitch हो सकती है. Okay. Yeah, coming back to this. So this is the eye chart we have done. Stability, S for stability. Yes. This is the normality histogram and normal probability plot with p value. This is called N for normality, yes or no? And this is called C for capability, where you are getting your Z bench value 3.93. Are you understanding? Just type yes in the chat box. Clear hai everybody? Super clear with this? So in one shot, as you become, instead of eye chart, it is showing X bar chart, where, Okay, here it is IMR chart, not X bar. It is called IMR chart. This is I chart, and this is moving range chart. Moving range is nothing but the distance between the consecutive data points. It is plotted. It is called moving range. Okay, so this is called IMR chart. It is kind of extension of I chart. Individual chart का extension. ठीक है? Super clear, everybody? Six pack analysis clear है? Just give me yes in the chat box. Very good. Now if the data is not normally distributed, then how do we handle that? Okay. How do we handle that? So ये file, I'm just sharing one file. Just open that file. And now we will do, if the data is non-normal, if the data is not normal distributed, how to handle the situation. Okay. So let's open the file which I've just shared with you guys. Once you open the file, let me know in the chat box, the file opened. Open, everybody? Super. So in this, there is a time data which is captured over here. So there are some extreme values. Okay. So if I do the normality check for this, if I do the normality check, go to stat, basic statistics normality test, select the time variable and say, okay, you will find the p-value less than 0.005. So this data is not normal data. The time column you need to select. Okay, you need to select the time column. Go to stat, basic statistics normality test. In the variable column, you need to select time. Once you select the time column, just click on OK. Just click on OK. And you will get this. Have you found this? So this data is not normal distributed, okay? Clear? So wherever the p-value is less than 0.05, it is non-normal distribution. Like I always give this example of, let's say your office, has the has your biometric system. Okay. So 9 o'clock is your time. So this is if I collect the people arrival. Okay. So how many people arrived at 8:30? How many people arrived at 8:40? How many people arrived at 8:50? How many at 9? How many at 9:10, etc. If this, when biometric is working, it will be a normal distribution. The moment biometric stops, people will start taking some advantage. They will start coming late and the distribution will go like this. Okay, this is 9 o'clock. Are you understanding? This is called non-normal distribution. Now, in the non-normal distribution, what happens is, because the data is non-normal, it might be creating more defects on one side and lesser defect on the other side, or vice versa, and we are not sure about it. Okay. So what happens is, whenever you come across this situation, the first thing what you need to do is increase the sample size of the data. Let's say if there are, now you will find this kind of trend when there are two situations. The two situations are, whenever there is a time related data. What is time related data? Cycle time, delivery time, downtime, okay, lead time. All these things are time related data. Changeover time. If you collect that amount of data, any data which is time related, you will find some kind of skewness in the data like this. So the first option is the time-related data, and the second option when low sample size. Whenever you have low sample size, there is a probability that you might get a non-normal distribution. So in that case, the first thing what you need to do is increase the sample size first and check the normality once again. Okay. If the normality comes, the p-value comes more than 0.05, then the data is considered to be a normal distributed. So increase the sample size in one aspect of it. If even after increasing sample sizes doesn't make any difference, then go for something called transformation. What is that? Transformation. Okay. So to do the transformation, let me just quickly. So go to stat control chart, box-cox transformation. Everybody can just follow this. Go to stat control chart, box-cox transformation. I'm just showing you one example. I'm just sharing the screen once again. So here you can go to stat control chart and box-cox transformation. If you click on box-cox transformation, all right, here you are saying that, okay, let me just check. All observations in the chart are in one column and observation of subgroup are in one. Yeah. So all observations are in one column. So specimen, no, it is time, right? So time you have to select and subgroup size is 1. Okay. Everybody following me? Go to stat, control chart. The first option is box-cox transformation. Okay. Yes. So if you click on that, select time, and in the subgroup size, say 1, and click on OK. Let me check the options. So option mein theek hai sab kuch. Click on OK, and you will get this option, this graph. Everybody with me till now? Everybody with me? Just give me yes in the chat box. Sabko mila ye? So this is called a lambda value. This also we have recently covered in one of the session, I think on Monday or Saturday session. It is last week only, right? So this is called the lambda value equals to 0. Now, what does it mean? What does this lambda value mean? Okay. Lambda value 0 meaning there is a table I'm going to share with you, which is already available in your black belt curriculum. Look at this. So whenever the lambda value is 0, look at this, you have to do log transformation. Yeah, look at this. Log transformation. When lambda value is 0.5, you need to do square root transformation. That means if you have the value 4, you have to take the square root of that. So you have to take 2. If you have value 100, you have to take 10. Like that, square root. Okay. If lambda value is 1, then you need not to do any kind of transformation. Okay. When lambda value is 2, you have to take the square of that. If the value is 2, you have to take 4. If the value is 5, you have to take 25. If the value is 6, you have to take 36. So it is called squared value. Similarly, if the lambda value is minus 0.5, then you have to take reciprocal square root. 1 divided by square root. Okay. If lambda value is minus 1, it is 1 divided by that value, which is reciprocal value. Okay. So this is the table, standard format table. So right now, our lambda value is 0. So we have to take the log of that. Now, if you remember, we used to carry the log tables during our school days and college days, right? Log table. How many of you remember log tables? The old day log tables, a lot of numbers used to be there, right? So what is log? We might have forgotten the log, but the log is something which is, for example, so let's say 10 raised to 1. Okay. So is equal to 10, correct? 10 raised to 2 is equal to 100, correct? 10 raised to 3 is equal to 1000. Everybody knows that 10 cube is equal to 1000, right? So the log value of understand this, log value of 10 to the base 10 is equal to 1. Log value of 100 is equal to 2. Log value of 1000 is equal to 3. How many of you got this? Just type yes in the chat box. So if there is 1000, value is 1000, you have to take 3. If the value is 100, you have to take 2. It's called a log transformation. Clear hand? Are you understanding? Super clear? Just give me yes in the chat box. Okay. Now what we will do, let's go back to the data. And now we will transform that data. Okay. Open the file once again. Okay, come back to the data. Now what we will do, we will create, okay, in the C5 column, just give the name log. In the C5 column, just give the name log. All right. What we will do now, go to calculator, go to calculator, store result in the variable log. So we will store the result in the column called log. And in the expression, we want a logarithmic function, right? So it's in all functions, just click here. Select logarithm. And log to the base 10. Okay. I repeat every process once again. Okay. Just go very slowly. Go to calc. Just it is besides the stat option. Calc में the first option is calculator. इसको click करो. In the store result in variable column में log को select करो where you want to select, what you can say, store the values. Then in expression, in drop down में logarithm select करो, logarithm, and log to the base 10. When you double click on log to the base 10, it will get selected over there. Just double click on log base 10. Log base 10. Okay. Double click on that, it will get selected. And after that, double click on time column because you want to convert the time column into log column, right? Just double click on time, it will get selected. I repeat again, I just remove this. I repeat again. First, you select logarithm. And in the logarithm, select log base 10. Double click on that. And then you double click on time. Okay. And then you say, okay. Now, what has happened is you have converted all the data points. Let's say 210's log value is 2.3222. Okay. 300's log value is 2.4771. Okay. Look at this. Let me just scroll it down. Can you see the 100 log value is 2? Okay, so we have converted all these time values into log values. Everybody with me till now? Just type yes in the chat box. Super clear? Yeah. So calculator may select the log here. First, store the data in log. Then select logarithm, log base 10. Double click on log base 10 and double click on time. And then say okay. Okay, this is a procedure. Here. Then now let's check whether the data has been transformed or not. Okay. इसका ना हम लोग क्या करेंगे? Let's do the do this histogram. Okay, histogram बना के देखते हैं पहले. चलो दोनों का histogram बना के देखते हैं. पहले time का बना के देखते हैं. All right. So this is the histogram of time. And instead of time now, let's select log. And this is the histogram of log. Can you see the difference between these two histograms? The first data of time, as I mentioned earlier, Look at this. Can you see a skewed distribution here? And now after transformation with the log, can you see the normal distribution coming out here? Can you see the visual difference between these two? Just type yes in the chat box if you can. Can you visually see the differences between these two? So a non-normal data has been transformed into a normal data. Clear? Super. Very nice. All right. So now here, let's do one thing. Okay. Now let's do, histogram. Simple, na? Histogram. How do you collect the histogram? Go to graph, go to histogram. The fifth option, graph mein fifth option histogram, right? Select with fit, say okay, and then select the column of which you want to create a histogram form. Okay, double click on that and it will get selected. So first you select log, first you select time and click OK. This one, the left hand side will get created. Okay, yeah, right. Now let's confirm with our normality test. Okay, go to normality test now. Instead of time, select log and say OK. Look at this. The normality test also is suggesting, earlier it was less than 0.005. Now it is 0.299. That means the data is normally distributed now. Clear? Super clear? All right. Fantastic. Fantastic. Super. Now, let's do the process capability analysis. Imagine, okay, now imagine the, yeah. So our, do we have 0 here as, so imagine our UCL and LCL are, so our lower specification limit is equal to 50 actually, okay, in our original data, and upper specification limit is equal to 400. Now, because we have taken the log data, we have to take the logarithmic data of these values, okay? So 50 ka logarithmic value and 400 ka logarithmic value we need to find out, okay? So can we just find out over here? So we have found out a 50 wala logarithmic value, which is 1.69897, okay? And transform it into log required to check whether the data is normal. Yes, exactly. ट्रांसफॉर्म होने के बाद एक बार फिर से चेक करना चाहिए कि डेटा नॉर्मली डिस्ट्रीब्यूटेड आया है कि नहीं आया, राइट? Yes, can somebody write down this value 1.69897? This is the lower specification limit का log value है. 50 है ना, lower specification limit 50, so उसका log transformation है 1.69897. Okay, very good. Now let's find out if we have any value of 400. Okay, 400 का कोई value है क्या? Yes, we have got 400 value over here. Write down 2.60206. 2.60206. Okay, so we got both the values. Now we'll go to stat, quality tools, capability analysis, normal, because it is normal distributed. We have transformed it. Okay, now select the single column as log, subgroup size as 1. In the lower specification limit, we need to put, what is the value? 1.69897, right? 897, correct? And in the upper specification limit, I will put 2.60206. All right. I'll go to option. I will select benchmark Z, say OK, and say OK. And here we go. So my current process capability in this process is 0.9 sigma process. It is 0.9 sigma process. This is my current process capability. Are you clear? So this is how you need to handle whenever you come across any non-normal distribution. First, you need to increase the sample size. Check whether it is taking the normal distribution shape. Are you understanding? Okay. If you are not able to get the normal distribution shape, then you can go for the transformation. All right. See, minimum 30 data points you should have. Minimum 30 data points. If you don't have 30 data points, generally you will get non-normal distribution. Whenever sample size is low and time-related data. In this case, this is a time-related data. Okay, that's why the normality was not there. Okay. So we have transformed that with the help of box-box transformation, log transformation, and with that we have converted into process capabilities. Are you clear? The procedure to handle the non-normal data? Just type yes in the chat box. Super clear, everybody? Amazing, amazing. Thank you very much. Thank you very much. Now, the people who have not yet, subscribed to our YouTube channel. Okay. Now we have just put it on YouTube as well. So YouTube meaning it is live. It will not be recorded in YouTube. It will be only for the paid members. Okay. The close family only. All right. But the other people also can learn from this. Okay. Of course, they cannot interact. They cannot ask the question like you guys can. Right. So please subscribe to the channel. Dinesh Patil YouTube. You can check Dinesh Patil Six Sigma. You will get the SNG wala logo and just subscribe to the channel. Okay, we are putting a lot of content nowadays. See, I was not very much active on YouTube as of now, but now I've started creating some content and putting the content because we have a lot of content with our we are doing the live sessions every week twice, and hackathons are happening. Green belt hackathon, black belt hackathon, the yellow belt sessions are happening. So much of action is happening on our platform. So thought of there is a lag between this and live, because whatever we speak in YouTube, it will be maybe a couple of minutes lag. Okay, but doesn't matter. At least those people also will get some learning. Okay? So if you have friends, family members also want to check this out, okay, they can just subscribe to the channel and they will get to learn a lot of things as well. Okay, yes, fantastic. Super. So what we'll do, it's already heavier stuff. So I don't want to bombard this tomorrow. We'll go for the hypothesis, advanced hypothesis testing, the p-value. Okay, how to calculate the one sample t-test, two sample t-test manually. Okay, so that is what something which we are going to learn tomorrow. Okay, then with the Minitab, then chi-square test and all lot of stuff, advanced regression, a lot of exciting stuff coming up tomorrow. All right. Yes. Yeah, so we are planning to do that, not yet decided. This is the first time we are experimenting, okay, Maheshji. But if it goes well, then we will definitely would like to spread this, okay, because YouTube is a big platform, and we can reach out to a lot of people. Okay, super. Yes, amazing. So yes, we have already studied the six-pack analysis, the non-normal data. Yeah, fantastic. Yes. Now you can see me live as well. Okay. Super. So we'll stop here. We will connect again tomorrow at 7 p.m. sharp with the analyze phase, black belt curriculum. All right. Super. Yeah, you start getting alert, because we have not shared the alert to anybody, because we wanted to check how it runs. Okay. That's why we haven't shared any kind of alert to anybody. Okay. But now from tomorrow onwards, we'll start sharing maybe emails and alerts as well. Right. Super, guys. Thank you very much. Keep learning, keep growing. The recording will be uploaded in masterclass, not masterclass. Okay? It will be hackathon folder. Okay, check out the recording. Do the practice once again to form up your what you can say, your concepts, and increase your confidence. Okay. Thank you very much for joining. This is Dinesh Patil signing off. Keep learning, keep growing. Bye bye. Take care. Good night.